Okay, maybe I think we can start our meetup. Daniel, it's really great to have you today. So Daniel is a chief product officer at DeepPavlov lab. It's a lab that developed a conversational AI framework, and it's a really great team that participated in Alexa Prize Challenge. And today Daniel will share, how they approach the problem of designing chatbots and AI assistants. Daniel, thanks for your time, and we're looking forward to your talk.
Okay, thank you so much for inviting me, and it's a big pleasure to be here, especially after Yosha Bacho was here like a couple of weeks ago, and I'm super privileged to give a talk at the same venue. And I think stuff you're working on is probably less sophisticated than things that Yosha encouraged us all to think about, but entertaining nonetheless. So, okay, let me start with a very simple thing. Why we at DeepPavlov are doing things in the conversational AI field and what we understand conversational AI field is all about. So to me and to us, the problem of conversational AI starts with the idea that we are like people who read lots of science fiction, and we are inspired by the very much idea that if people can say something to the system can understand them and make that wish happen. And this is a very simple but yet very, very powerful idea. And I mean, yeah, obviously we need to have lots of infrastructure. So if you say, Alexa, order me some pizza, and it will understand you and bring you pizza at some point, obviously it's the work of lots of different elements. But the key problem, the key metric here is how AI system can actually understand what people say. And this is a challenge. This is the biggest challenge that I ever faced in my entire career, and my career started like in 2005, and I've seen some things. I wouldn't say that I've seen everything. The field is super huge, but this is like the biggest challenge I've ever seen. And the problem with AI assistants is they are having like very poor usability. So there is, famous Nelson Norman group, and they made the UX study like 2018, and it's still real. It's still very much true. And they try to understand how AI assistants actually work. And the example of the fact that this field is very challenging is that the results are from 2018, and yet they're very much up to date. We still have these very challenges. So the AI systems of today, obviously, they're very complex systems. They have to recognize speech. They have to understand what user said. They have to interpret what user actually wanted to recognize their intent. Then they have to figure out what kind of APIs have to be called to fulfill users' requests. And then they have to come back to the user and provide some response. And if you look at all of these levels, it's a lot of red, and this red is one of the reasons why field is so awesome and yet so complicated. We know that speech recognition for English language is pretty much great, and the limitations start once you have an accent like I have. And when you go to other languages, the challenge is even greater. For example, in Russia, lots of people speak very different accents. They come from all parts of Russia and the ex-USSR. They have different accents, and it's a big problem for Russian AI assistants to recognize that. And in the United States, we have so many people who speak different languages because they are first-time immigrants or descendants of immigrants, and they also have this problem with accents. And that's like the least problem of all problems we are facing. And the way how I would call it is like, as a holy grail of NLP is to make computers comprehend human language. And I know that that sounds probably very emotional, but on the other side, it's indeed super hard. For us, we at DeepPavlov decided to pick these three problems. We decided to focus on natural language understanding, intelligent interpretation, and we are slowly but steadily working on the agency problem as well. And these problems are so big that we decided to participate in different challenges, because these challenges, they help us to accelerate the speed at which we can actually build anything, build solutions. And in the last 3 years, we've been really happy, very proud of the fact that we participated in the Alexa Prize Social Bot Grand Challenge. The Grand Challenge is easy, so it's not like a Turing test. I mean, people do know that they speak to actual social bots. They know that there is no human on the other side. So when you say Alexa, let's chat, yeah, it will tell you that there is a social bot running there. And those social bots are built actually by university teams. And our lab is actually part of university. And the problem is that we have to build a social bot that can support an interesting conversation for 20 minutes and get a rating 4 out of 5. And as you can see, like in Alexa Prize 3, the best team, they achieved 7 minutes, 32 seconds of supporting an interesting conversation. And this time, Czech team Alquist, they participated by the way in all Alexa Prize challenges. So they are super amazing team. They sustained it for 14 minutes, 14 seconds. Yet the problem is ratings are super hard to get. So you can, for example, you have a trade-off like what we discussed with Mike at the beginning. The trade-off is either you try to focus on quality of the conversation and then you put a lot of effort in scenarios, or you can try to aim for supporting long conversation, but then you will definitely lose the quality of the conversation. You can use GPT-3, you can use BlenderBot, you can use different generative models to support interesting conversation, but you won't be able to control it. So this is a huge challenge. And for us at DeepPavlov, we decided not to just participate in the challenge, but we decided to build our own platform. So Alexa Prize, when you participate in the challenge, Amazon provides you with a framework. They call it Chatbot, conversational bot. And in essence, it provides you lots of APIs to sentiment analysis, to topic classification, dialogue classification, entity recognition, factoid question answering, all of those things. What we decided to do is we decided to build our own small platform. And we decided to use this platform to later make it available to everyone. So for example, just to clarify, my first job was at Microsoft. And for a long time, I was not a fan of open source. But ironically, in the last few years, I've worked in the organizations which facilitate open source development. And right now, we're building open source platform. Everything we build is Apache 2.0. So ironically, what we're trying to build is something like Linux, but for conversational AI. So we're trying to build a platform where you can build your own multi-skill AI assistant like Alexa or Google Assistant or I don't know, Cortana, even though it's in a half-dead state, by yourself. And the best way we could develop it was participating in Alexa Prize challenges. So the idea of the platform is very simple. I'll try to draw. I'm not sure it's going to work well, but let me try. So the idea is very simple. In the beginning, when user starts the input, and in case of Alexa Prize, we just get ASR, so we get a result of speech recognition. User query goes to a set of annotators. Each of those annotators is extracting different pieces of information about user. It can be sentence segmentation in the beginning and sentence rewriting sometimes. But then we extract things like entities. We understand sentiment, emotion. We try to understand if user is toxic or not. We try to understand if user is actually doing question answering, so factual question answering. We try to extract characteristics of the utterance based on its dialogue using PINDAS. and Amazon technology called dialogags that they have. They're different from Midas. They're more primitive, but they work more or less. And we use all of these things to have a very big understanding of what the user actually is saying to us. And then when we've got all of those annotations about what user said, we send these annotations to a thing called skill selector. Now, if you are familiar with Alexa in everyday use, beyond just talking to itself and using its inbuilt scenarios, you are familiar probably with the skills, right? So you can go to Papa John's, you can go to Domino's, you can go to your banking skill, and so on. But to invoke them, you usually have to name a skill. So like Alexa, open the skill, and then you have to interact with the skill. And then you exit the skill and come back to the main scenario. So in our case, what we do is we make a skill selection transparent. We use all of these annotations, richness, all of these annotations to actually realize what user wants. And then we pick skills that generate response to the user. The skills can be different. We have retrieval skills, like based on convert Reddit. Unfortunately, this data set is no longer available, but it used to be, and we still have a private copy of it. It can be something based on patterns. If you ever heard about Mitsuki, a email-based bot that won Turing Award for 3 times, it was actually built on AI markup language, and we used it. We didn't use the bot itself, we used a simpler version of it, but nonetheless, we used it. We used generative skills using Blender bot. And we also built lots of scenario-driven skills. So for all these things, most of the things are scenario-driven. And it's interesting. You might look at me and say, hey, Daniel, so you work in the conversational AI field. And like you have heard about GPT-3 and BlenderBot and other things, why the hell you're using scenario-driven skills instead of using generation? And the answer is generation is super hard to control. When you try to control generation, you face a lot of challenges. So, for example, it can contradict itself. It can start lying right in the moment when it speaks to the user. It can say at one moment that they like blue color, and a few more utterances later, it will say like yellow color. And these kind of challenges are awful. So just to get back to one of the previous slides, to this one. As you can see, the team in Alexa Prize 3, they got a rating of 3.8 for 7 minutes, 32 seconds. While the Alexa Prize 4 winner, they got 3.8, 28 rating, and they sustained it for 14 minutes. And the difference is exactly here. So the team in Alexa Prize 3, Humora team, they built their own framework for designing scenario-driven skills. And they achieved a high quality conversations with their end users, but obviously they didn't sustain for very long. While at the same time, Alkus folks, they decided to add in more generation into response of the system. And while they sustained it for 40 minutes, which is twice as much, they went to a way less impressive number. Way less impressive rating. So that's why scenarios turned out to be a very big tool for us for designing and controlling a dialogue. But in any case, once all of the skills generate responses and we pick those skills in skill selection, we go to another group of annotators. And these annotators, they understand sentiment and emotions and toxicity. They help us to basically remove words, remove responses that might make our user unhappy. And after all of that stuff, we make hypothesis scorer do its work. We use the hypothesis scorer from Amazon. And then we pick the best response or combination of those responses and response selector, which in the end provides a response back to the user. We actually also do some annotations before going back to the social bot, but those annotations are mostly used on the next turn of the system. And this is obviously not only useful for building social bots, but also useful for building platform, for building your own AI systems, because you can definitely plug your own third-party skills into the system. And as long as you can control response selection automatically, you don't have to make users use this artificial approach of like call book skill and then talk only to book skill, because at each step system can go to book skill or any other skill, and still maintain a more or less natural conversation. Okay, so the thing is, everything I told you about our platform is just a part of this iceberg of conversation as we see it. I don't want to focus on everything here on the slide. I would just highlight a few things. That what we have is, we have a story about goal-oriented understanding of what user says. We have some slot filling, and we have zero-shot slot filling by using entity linking, which identifies entities in user utterance and links them to Wikidata, and identifies types of those entities and provides this information back to the system. So you don't even have to train your custom slot filling for the types that are provided by Wikidata, and there are like hundreds of types in Wikidata. We work on empathy kind of things. We have different kinds of annotators for topic classification, other things, and so on and so far. But the big challenge is how to design skills and how to control dialogue, how to make this whole thing work. These three things are the biggest challenge for us. And what we focused on in the last year was focusing on SDK for building skills, for building a designer for building skills, as well as automated skill generation and semi-automated scenario generation. So these kind of things are what I'm going to talk later today. And I want to challenge your perspective if you feel that generative models are the only way to go, that actually you can achieve way more if you combine scenario-driven approaches with generative-based approaches. Okay, so
Daniel,
why?
A quick interruption. For those
Sure.
of us who are not as familiar, could you make the distinction between scenario-based and generative the way you're explaining?
Yes, absolutely. That's actually what I wanted to say in the slide. Absolutely. So when you use controlled response, when you use a response generation using large generative models like GPT-3 or BlenderBot and so on, you use the following approach. You can provide some prompt to the system. You can control a few things in GPT-3 model, for example, the temperature and other things. But in the end, when it will start generating responses word after word, you cannot actually control what it's going to provide to you. The cool thing about large generative models like GPT-3 and the one that DeepMind published post about a couple of days ago is that it can generate phrases that will have meaning. The problem is you cannot guarantee that they always have meaning. The problem is that you cannot guarantee that they will actually be a response to what user said or what user asked this model to do. You cannot guarantee that they will be not contradicting themselves. You cannot guarantee that they're not going to lie. But in all, they can provide you some meaningful or seemingly meaningful responses. And the thing is, if you have the generative model, all you have to do is to provide it the user utterance and then ask it to generate a response. One of the tricks, for example, could be this. So user says something. You add some prompt to the system. And your generative model, like GPT-3, it will provide you with a response. Then you will go back to the user. And now user will give another response, and you can cycle it. And it's very easy, especially if you use inference made by not even your computer, but some servers in the cloud like OpenAI or Microsoft Azure or something like that. Now, scenario-driven approach is different. Scenario-driven approach means that you actually try to design dialogue around conditions upon which user would get into one of the nodes in the graph. So this will be node number 1, this will be node number 2, node number 3. And at each step, user can go in absolutely different kinds of directions. And we'll talk about this in a couple of minutes. And the problem is, the good thing about this is if you got the condition right, you can control what the bot is going to say at each step. And if you have tools for designing narrative of your social bots, just a bot, or AI assistant, you can have a very meaningful conversation. The downside is you have to predict all of those conditions, and once the user will respond with something that you didn't predict, you will get into trouble. Does it make sense to you?
Yes, yes. But even with conditional branching, you might still experience that scenario where you do not know what to do, in which case it will fall back to the regenerative or response base that you were talking about.
Precisely. And this is exactly what Alexa Price for teams, including ours, did. So we used a combination of scenario-driven approach with generation. This is precisely what we all do. The thing is, we believe that we can do more. So in the last year, starting with January, we designed our own framework for building these scenario-driven skills and individual chatbots. We call it DFF. It's Python-based, it's Python native. You can just do pip install a Dialogflow framework, and it will give you a DSL. And this DSL is very simple. You simply define the plot. A plot has lots of flows, and each flow has a node. And from node to node, you have transitions. You can control response. You can annotate each of the bot's responses in the way how you want. And then you design the entire thing in this conditional branching. It's very easy. And this is not rocket science, obviously. The rocket science comes later. But we had to design it because we used a framework from the winner of the last year, Yamura team, but their framework was very hard to use. In fact, we had to go through 2 iterations. One, we had to adopt their system and transform it to Python because it was easier to code in Python that check all the conditions they had in text. And then we had to rewrite this Python-based framework practically from the very beginning and introduce this DSL. So in the end, what you see here has historical connection to Yamura framework called ESTDM, but it has like no code from them. It's our own framework. And it has a lot of things. You can have entity detection, intent classification, you have dialog acts and speech function classification, it has a dialog analysis dashboard. And this is something we're going to focus a lot in the coming year. And approach, as I said before, is very easy. So you have a complex system and you design this conditional branching based skills or chatbots. And this is how it practically works. It's very easy. But obviously, there are lots of those downfalls. The question is what's different. And here I apologize to Sophia, but this is going to be a quote. I'm pretty sure you have heard about it, that there is no plan that survives the first battle. And everything you do after that first battle is conditioned on the outcome of that first battle. The problem when you try to design something using conditional branching is you have no clue what your user might say. No clue. And if you build goal-oriented chatbot, you at least can build some set of intents. And even that is not very easy. You have to collect those intents from somewhere. But if you try to build an open domain chatbot, which can discuss anything, you are in trouble. User can say anything. So like bot says, hi, how are you doing? Can user say hi, or maybe what's up, or I'm sad, I had an awful conversation with someone, switch off lights, and how the hell are you going to recognize it? Okay, so switch off lights is easy. You can build skills that will just recognize smart home management, and that's about it. But what about everything else? Obviously, you can use different patterns. You can use regular expressions. You can do intent classification, and there are even things called dialog acts that are like abstract intents. They come from logical philosophical part of the linguistics theory, and they things like yes, no, question, statement, other things, and they can help you. But you still have problems with how to react, and sometimes all of the things might be not enough. So the question is how we can try to design a dialog very quickly without having lots of data about the user. And this is ironic. We people love to talk. We people like have lots of communication stored in WhatsApp, Facebook Messenger, SMS, and so on. But most of this data is never available for developers. And this is a big challenge. For us at Alexa Price, it was such a big challenge. We had to build lots of different tools to solve this problem. And this is one of the things we discovered this year. So there is a book called Analyzing Casual Conversation. I mean, we've read different things. We've learned about discourse in general, dialogue acts, speech act theory, utterance acts, lots of things. But then we stumbled upon this book, Analyzing Casual Conversation. The book was written by Agassiz and Slate. They're still alive. They are in Australia, senior directors. They're fantastic researchers, distinguished researchers in the field. But what they did in 1997 was amazing. Unlike dialogue acts and speech acts that are usually pretty much single turn, like you realize that the user asks a question, you certainly can realize that you might answer with a statement, but that's about it. What they came up with was the idea is that in a dialogue, you can have discourse structure patterns. These patterns, they operate across turns. They are interactional, they're sequential. So in general, users, they can act in the conversation based on their choice of speech functions. And you can imagine the entire dialogue based on those speech acts. I have a picture in the next slide, but I just wanted to illustrate it here, if you don't mind. So user says some speech function 1, and there is a probability that user might go into speech function 2, the next user, the opponent. And the first one might go with the speech function 3 and so on, because there is logic. There is sequence of speech functions going one after another. And this like changed everything, because when we had dialog acts coming from Midas, which is a classifier built by another winning team from Alexa Prize 2, Gundrock, we only could recognize that we have turn 1, and we can realize the dialog act of this turn. And we can somehow realize what we might say because we know this dialog act, but we don't know what to do next. But once we learned about the speech functions, we realized that, holy cow, we can actually try to design dialogue based on predictions of what the next speech function might be. And this is how discourse management works, at least in theory. And that's what we experimented a lot in this year. And we presented our work in this field a little bit more than a month ago at EMNLP conference in Dominicana. So here's the deal. When users say something, they actually make a discourse move. And this move can either be opening or sustain. The trick is when you make an open move, you start a discussion about something new. If you sustain, however, you continue discussing the stuff you've been already talking about. So in the first case of, let's imagine that I'm talking to Sophia right now, and now I ask Sophia something like, Sophia, like, how did you spend your last weekend? And we had a conversation about dialogue acts and many other things. And then I make an interruption of sorts. I change topic, change it completely. And this is when I do an open speech function or open discourse move. But if, for example, Sophia would interrupt me, or like, Anindita, I'm sorry if I pronounce your name wrong. When you interrupted me and asked me a question, you actually made a rejoinder. You asked a follow-up question to me. You asked me to further expand what I've been already talking about. Does it make sense?
Yep, absolutely.
Yeah, excellent. So this was fascinating. When we realized this, we realized that there is some fantastic ideas here. And the thing is, typical dialogue acts, they are designed in such a way that they have a small amount of information in them, like statement and question. Yeah, that's like cool, but so what? But speech functions, they are different. So for example, we have an open move, and in it we have initiate. And in it, we can demand something, and we can demand, have an open demand, and we can have demand for information, which will be, for example, fact. So as you can see, a lot of information is encapsulated in one single speech function. So open, initiate, give opinion actually encapsulates a lot of meaning inside it. And the thing is, there is a limited number of speech functions in their taxonomy. I'm not sure if I do have a slide with them. Yeah, unfortunately, I don't have a slide, but I can share the slide later to Sophie and share it with all of you. It's just like 42 speech functions that Eggins and Slade designed. And they designed the speech functions based on the Holliday's idea of speech functions. M.K. Holliday was a founder of functional linguistics. He also lived in Australia. He has a fascinating mind. And he found these speech functions based on data. This is interesting. So he observed how kids were learning language and how they use language to communicate and to interact with their interlocutors. And over more than a decade, I believe, he made those observations, and that's how this idea of speech function theory was born. And then it was obviously developed, and at some point it came to this concept of speech functions and discourse moves. And this is important because this gives you as a developer of scenario-driven skill or a chatbot advantage. Now you can plan ahead what the user might say. It doesn't mean that you have to avoid intents. They might still be useful. But this gives you a lot of information that previously wasn't available to you. But obviously, this works only if you have a speech function classifier. And boy, we made one. It's still in progress. We are working right now on labeling a huge data set based on daily dialects. I'm pretty sure that those of you who work in the conversation, I feel they are familiar with it.
Actually, Daniel, how do you label it? Do you do it internally, or you?
Excellent question, Sophia. So what we're going to do is we're going to run it through one of the commercially available platforms, Toloka. We wanted to do this from Mechanical Turk from Amazon, but it's so hard to design UI experiences in Amazon Mechanical Turk. We decided to build it on Yandex Toloka. And I actually have a colleague of mine, Marie Molchanov, who designed it with colleagues, the whole process. So I'm not going to show a slide from this. I don't have a slide with what she designed, but this is fascinating. In general, users have a user interface with what one interlocutor says, what another interlocutor says, and so on. And we created a fog of war, like in computer games, like in Civilization and so on, where user says only one phrase, one utterance. Everything else is hidden. User has no idea what's going to be said next, like a classifier, because classifier has no idea what's going to be next. And when user classifies one utterance, they go to the next one and they see it and so on. And because obviously users have no clue about speech functions or speech arc theory or anything like that, our team, they designed a questionnaire that helps people to label data and still come to the speech functions we need without understanding what the hell is going on. We still give them some kind of instruction, but it doesn't require them to understand the theory behind it. So like everybody here in this talk, all of you have bright minds and you definitely can grasp all of these ideas. But from our users who can label data, we don't ask the same level of sophistication because we want to have a broader audience labeling data. Anyway, so we decided to build a tool. The code name is DDIDD, and when we called it this way, the idea was simple. It's discourse-driven integrated dialogue development environment. But then somebody decided that there is a resemblance to ID Kukudi from Doom. which is like a God mode for Doom players. And we thought like maybe we could call it like a God mode for Dalek designers, because we really want to make development of Dalek systems easier. So we built this tool. Right now, this is how it's called. We're going to call it differently. And it's actually available in Visual Studio Code Marketplace. You can try it out. It's very buggy. It's very early in the development, but you already can try it out and try to build something. Let me show it to you. So it's an extension for Visual Studio Code. You just go to Visual Studio Code Marketplace and download it and install it, and you can try it out. It has instructions, so you'd have to install also our SDK. You have to run it in Docker Compose because it has annotators that are important for recommendation system. We'll talk about it in a minute. And what you do is you try to create a skill using or a bot using this framework, and you try to design it visually. So that's how it works. I can reopen the editor with our designer. Right now, designer is built on Draw.io, but we're going to rewrite it. We're already rewriting it because Draw.io has an enormous code base, and it turns out it's a bit easier to use something very small and then add features that we need. But this prototype is built on top of it. So that's how it works. You have a starting node, and that's how you begin the conversation. If you want to just to test the system, it's easy. You go here, you just say Python 3 and you go to the file. You say something to the system, and because there is nothing here, the system will say, oops. And this is seen in the code. So open this text editor. You see, we have said nothing, so we'll go to fallback node. It's very easy. But we can control the dialog by clicking this button. This is where we give recommendations to the user. Some of these recommendations are easy, not recommendations actually. That's just conditions you can use, regular expressions, exact match, or some custom conditions. But we also give you these recommendations of speech functions, open demand fact, or like open give fact, or a rebound, or give opinion, and other things. And these things, they work on top of our speech function classifier. So the one we built, we label data for ourselves. And we built lots of rules from linguistics to make it work more or less. And that's what we have in our alpha. So imagine we want to build a very simple skill which talks about lasagna and Italian cuisine. So we can expect user to, for example, say us that they want to demand a fact, like how do you do? So just double click on an item, and I say that we want to respond with clarify. And what happens here is interesting. So when I click on suggestion, suggestion will be the next node of our system, how the system will respond. Well, these things are conditions. And when I pick one of these suggestions, I pick the speech function of this node. Here we have a few of them recommended, but in later UI, you will be obviously able to pick other things as well. What is interesting, we have probabilities here. So system has some data that we already labeled, and we built a predictor. And predictor says that the most obvious thing to begin conversation is to end it by say resolve. And this is indeed reality. A lot of people say hi, and they say hi, and that's how you end the conversation, and so on. But we want to actually have a conversation. So we want to clarify something from the user. So let's click save. And now we have a couple of nodes here. We have one node and we have a transition. Let me save it. Let me take a look at the code. That's what happens. We created a node suggestion, and we got here based on the condition open demand fact. What's interesting here, we didn't specify any kind of a custom intent. We just said that we have this open demand fact. Let's try it out. So I say Control C, and I say, how are you? What's interesting, the system realized that this is an open demand fact. And because we didn't say anything, we say, oops. But we could do something and try to do something. So open demand fact, we say, what kind of, like, okay, do you like lasagna? Run it again. How are you? And this time, yeah, you see, do you like lasagna? Because this time we've gotten to the right node. And the cool thing here, we didn't have to build any kind of intent classifier. We just use speech function classifier to understand an abstract intent of the user without going deep into the details. The fact is the system actually can grasp lots of details. Let me show you a bigger scale. So this was a very simple one. Here's what we designed it with the tool. I'm sorry, misclicked. Open with DDIDD Dialog Designer. So this is a much larger story. Let's try it out. So, hi, the system will give us some sort of a response, and we can go obviously through the happy path. That's when we do planning, right? So when you design a conversation experience, you have some notion of a happy path where you put nodes in some sequence, and you believe that user will go through those nodes. And in this case, the other thing is, yeah, system understood that this is a firm, and it went through its path, happy path. Oh yeah, so similar, blah blah blah. But we can try to break it a little bit. So on, and I say hi, and then when I say like, I can say I like pizza. This is interesting. Now the speech function of a user set is, let me click, where is it? So speech function was resolve from the user. And we have not prepared for the resolve. Yet the system managed to provide us a response. Why? What did it say? It said, oh, I really don't know what to say. Do you want to talk about cuisines of the world? We have a fallback node, and it helps us to still continue the conversation. We can pick different kinds of responses, and in some cases, we will get into a more interesting situation where, try it out. It's going to work, but let me try it out. Let's see if it's going to change. Yeah. So now I changed my phrase a little bit, and now the system realized that I'm extending the existing part of the conversation. And here, the system provides us a response, oh, I understand. Now, if you look into the system, kind of conditions we have. Now, this is one of the reasons why we decided to not use Draw.io. It's hard to use it. We have extend, elaborate, register, enhance, and so on. But some of these responses, they will be not prepared by us. The system can just use a generic response based on statistics and give it to the user. And then it can go back to the user with its query based on the happy path. So this is what happened. We said, oh, I understand. And then it attached a question of the next node. Do you like pasta? So coming back to the slides, this is what we do. This is what we've done. We are in condition here. User says something. This is a happy path. But user said something different. And we didn't predict exact phrase of user, but based on speech function, we can realize that the user actually said something that we can sort of skip. We can give a sort of meaningful response and then jump back to the happy path. And this is available for us, and this is available to you, obviously, because speech functions, they're generic enough, and responses are generic enough that we can go back to the happy path, and the user might not even realize that we didn't understand user at some point in the system. Now, I'm not sure if you're still following me. It required me to explain these ideas to our crew in the lab for like half of a year, and they still complain from time to time that they don't realize what to explain. So if you don't understand, feel free to ask me questions.
Daniel, I'll ask one more time. So let's assume you have a set of session attributes that you keep populating. And so every time the user strays away from your intention of where he should stay, you give him some response to say that you are still in charge and then guide him back to the happy flow so that the previous things that you have learned about the context is not completely destroyed?
Yes, that's true. So in the bigger system, in our social bots that we built for lecture price and the platforms that we're going to launch later this winter, we actually have a huge dialogue state that travels with the user during the entire conversation with the system. And even a smaller chatbots based on this framework, DFF, it's the same happens. We still maintain the context. So it's not completely lost. Obviously, if user goes to fallback node, which we try to avoid, then we might lose the context. But we are not technically losing the context. It's harder to process fallback node than process such as some of the speech functions. Does it make sense?
Yep. Now, are you talking about all of this in the context of text, or is it still voice? Because I still feel the hardest problem is understanding voice properly.
So yeah, good question. So in our case, we focus on what speech recognition brought to our system. We don't focus on combining speech and NLU together, because in Alexa Price Challenge, we used ASR from Amazon. And in our own platform, we use a framework called NeMo from NVIDIA to do ASR. We are not experts in ASR so far. But I agree that when you can combine language model and speech recognition together, you can yield better results, that's for sure. But usually in large solutions like Alexa itself or our solution, you don't have this luxury of combining those things together. You usually have to transform data into the text. The question is, can you use other attributes of the text? But that's a different subject. That's one of the things we are starting working on by adding multimodality to the system. That's a very fascinating topic for discussion, but probably not for today's one.
Got you. One last thing, that initial slide that you showed with all the distinctions, and you highlighted 3 things on the left and maybe 2 things on the right that you said you would focus on. Are they little mini models that you're using behind the scenes, or are they, logic in code?
What do you mean by models? Do you mean annotators, or do you mean something else?
Maybe you can.
Yeah, actually, what is annotators? I don't know.
To understand what
So annotators, that's how we call models that allow us to annotate data. So automatically annotate data. Yeah, by the way, it's a good question. Somehow recently I had a problem with saying annotators, and people thought that I was talking about people. So annotators are not people. Annotators are machine learning models, like entity extraction, sentiment analysis, topic classification, dialogue classification, speech function classification, all of the things, we call them annotators. And we use those models to annotate every single user turn. So
are you using external models, or you built all those modules?
Oh, gotcha. So in Alexa Price Challenge, some of the models we've used were provided by Amazon, but in the platform we built, we have our own models for everything, for dialogue acts, for speech functions, for named entity recognition, for entity detection, for entity linking, for question answering based on knowledge bases, for question answering based on open domain text, and so on. We use our own models.
Got you. Thanks.
I think, we have a bunch of questions, and I have a hard stop at 11:30. If you don't mind, Daniel, I will start asking.
Sure. I'll be happy to answer the questions. I think we more or less got to the moment where I'm happy to answer questions. Not that I wasn't happy to answer questions before.
So the very first question I see was from Dave. He asked, what is the difference between natural language understanding and intelligent interpretation? So you when you were showing your slides, you had those 2.
Yeah, a great question, Dave. So let me explain it this way. So for example, we have the speech function, which says, it's a very simple one, open, demand, fact. And why it's called demand fact is obvious. Why it's open, the question is, user might demand fact, tell me something about something. Or they might expect you to give a very straightforward answer. yes or no. If you say yes or no, this is a closed. So open demand fact is when Bill Gates was born. And the closed demand fact is was Bill Gates born in 1952, for example. I'm not saying that he was born in 1952, just example. If that makes sense to you, then the thing is that when you classified user utterance with this open demand fact as a speech function or something similar from dialogue acts, you performed some sort of natural language understanding. You realized that user wants something from you, but you don't know what exactly they want. So when I asked, for example, Sophia, when Bill Gates was born, the system can say, yes, Daniel just asked open demand fact. How does it help Sophia to understand what the hell did I ask her about? For Sophia, it's very easy. She can recognize and transform that in very specific intent of sorts. That I'm talking about birthday, then I'm talking about Bill Gates, then she can either go to memory or she can query Google, because who the hell is going to remember when Bill Gates was born anyway, and then come back to the response. But for computers, this is a challenge. We can understand that there was open demand fact. We can probably understand that there was Bill Gates mentioned, and maybe birthday. But how can you go from open demand fact, Bill Gates and birthday, to the fact that we're asking when Bill Gates was born? So the first thing is recognize all the things in natural language understanding. And the moment when you realize that user actually asked when Bill Gates was born, this is interpretation. Does it make sense?
I hope it does.
Okay.
I see a question from Ivan, like actually two questions. What do you mean by agency, and how do you handle uncertainty in recognizing users' intent?
So agency is a good question. Agency means that system can act on itself. So like the worst case scenario, you are in Stanley Kubrick's Space Odyssey movie, and HAL decides not to open the door, pod bay doors, because it has different agenda for itself. So agency means that your bot has its own agenda, their own goals, their own needs, that bot wants to address, bot wants to achieve those goals, make them happen, make them real. And usually bots don't have that. One of the areas of research we do at DeepPavlov right now, and for the last half of a year at least, is how to recognize goals of the bot and the user, and how to incorporate that into making a conversation interesting. Just to give a very simple example. When you talk to the user when bot talks to the user about something, and user asks bot about something in any domain, if you just design scenario-driven skill and we write down scenarios by hand, bot doesn't have its own response. It just says what we designed at scenario-driven skill. But if bot has its own opinion about something, if it probably has some experience about something, then the bot probably could respond based on all those things. Bot could probably say, don't want, for example, so I want to talk to bot about colonizing Mars. And bot might come back to me with a response, yes, I love colonization of Mars. It's a fantastic topic. I was dreaming about moving to Mars and then having my own computer there and living there. Or while different bot might say, I'm not going to go to Mars because I want to solve problems on the Earth. But this happens when the bot itself has its own agenda, when bot has its own interests and goals. So that's how we interpret what agency is. And a more simple explanation, agency is also about when bot can do something on your behalf without asking you. It's like they can switch off electricity in the rest of your house when you go back to work, or it can order some replacements for your washing room or something like that, not asking you because they know that that's something they can care about.
Basically, you're talking now about more like AGI level.
Yeah.
Okay. And how do you handle, what was the question from Ivan? Just a second. How do you handle uncertainty in recognizing users' intent?
how to recognize uncertainty, how we deal with uncertainty. So, well, this is a typical story. You usually have a probability of how well you realized what user wants. And if you go like lower than some level of that is acceptable, you can just re-ask user what specifically they want. There are different approaches to that. For example, it can be form filling. This is very specific for task-oriented scenario. So when user wants to order pizza from the system will ask clarifying questions until it will collect enough data to make an API call. In more general terms, that depends on scenario.
Ivan, do you have other questions? You can unmute yourself.
Yeah, I mean, question was basically, do you have any threshold for a certain amount, and you answer it? Yes.
Yes, of course, but the threshold is usually something that is taken into account by specific skill designer in our case. So we have a lot of people who've been building different kind of skills for the system, and they've been picking those kind of thresholds. It's a try and tell story. It's not like we have full answers for everything. By the way, I wanted to highlight something, if you don't mind, all of you. There's a couple of things here. So I told you about the idea that when you have speech function classifier, you can predict the next step for the user, and that's how you can quickly design skill without running it against the users. But there's one more thing that I wanted to tell you about, and that's pretty much an interesting idea from my perspective, at least from my perspective. So imagine you already collected some data from the system. So you've got into the first bottle, you already talked to your users, and you've collected some data. So what we've built into the system, and that's how the UI is going to look like once we get rid of Draw.io. A user will have a chance to show suggestions, and sorry, not this kind of suggestion, different one. So user will be able to click on condition and realize that maybe this condition can be splitted into multiple conditions to go into further dialog tree conditional branches. So this is something you cannot get from recommendation system based on statistics and logic, but something that you can get based on your actual data. I just wanted to wrap up the idea that with our tool, you will be able to, you already can design your happy path before starting conversation. And in the next few months, you will be also able to see how actual data looks like and further refine your dialog skill based on the statistics. Okay, now I'm ready to get back to responses and just realize that this was something cool that I wanted to share. Sophia, your turn.
I see a question. What are you planning to use instead of Draw.io?
We actually have some React-based framework for zoomable user interfaces that we're going to use. We actually already have some user interface prototype. I'm just not ready to show it yet.
Mm-hmm. So, Dave was asking about the book that you mentioned.
Yes.
Eggins and Slade. But
Eggins and Slade, analyzing casual conversation.
Yeah, what was it typo? Because on your slide it was Eggins and Martin.
That's because that was a quote from the book, and they themselves quoted an earlier work, which was made by Eggins and Martin. But the book itself is written by Eggins and Slade.
Mm-hmm. Okay. So Dave was asking, what is the commercial purpose of this social bots that can, support casual conversations?
This is a great question. So when you want to build an AI assistant, and it's like Amazon, Google, and other big organizations, Samsung, for example, Yandex in Russia, Sberbank in Russia, some companies in China, in other countries, you usually have to design the entire system around a few ideas. You have some core scenarios. You have to have a third-party marketplace for skills. I think Amazon has more than 120,000 skills in the marketplace these days. And then you have to address two more big scenarios. One scenario is question answering. Google has luxury of their Google search engine. Yandex has the same thing. But then there is one more big scenario. Users want to talk want to chat with their chatbots. And the problem is it's not very easy to build an interesting chatbot. I know that people at Google Assistant, they built some sophisticated scenario-driven things for supporting some visual conversations. I know that Replica, they made something fascinating with combination of scenario-driven approach and generative models. And Amazon, instead of building their own chatters, actually made this whole competition and people talk to those social bots. So usually when you want to build open domain story, it's about building a complex AI assistant. And you usually want to build a complex AI system because you want to build an ecosystem around your product. That's what lots of companies across the world are doing these days. It's automotive companies, for example, when Mercedes went to SoundHound to build the AI assistant into their cars. It's Sberbank in Russia, which decided to build their own AI assistant. It's Baidu in China that built their own AI assistant, and so on and so on. So that's where you usually use it. And there are other cases. One of the cases is your own psychotherapist. So sometimes it's not very cheap to have your own psychotherapist. But you can build a software and provide it to people, and they can talk to the psychotherapist and get some advice. So that's one of the other cases. I have friends who work in this kind of stuff, and it's fascinating what they achieved. Sophie? Sorry.
Daniel, I have a question. So you said earlier today that we generate lots of text in WhatsApp, in text messages, but basically this data belongs to Facebook, right? And those kind of companies. How did you guys build your data set? Basically, what kind of data set did you use?
So this is a painful question. So we have to scavenge a lot. That's, I think, what all of the open NLP labs doing across the world is scavenge a lot. So like it's Daily Dialect, which was collected about 5 years ago. It's Switchboard, which is like more than 20 years old data set. And for us, we were fortunate to participate in the Alexa Prize competition. So we have data sets collected from two competitions.
Okay, understood. So the user who asked about Draw.io, it seems like he didn't catch your answer, like about if you're going to replace Draw.io or you're building your own library. Can you please clarify?
As I said before, it's just one of the React native, not maybe native, but it's one of the React libraries that support visual graph layouting.
Okay, do we have more questions? I mean, Daniel is a part of Bugout community, so you can find him on our Slack. And Daniel, if you don't mind, please share presentation, right? And if there are other supporting materials that you want to share with the community, please do. And
sure.
I see Ivan is asking, do you have any tips for creating domain-specific chatbots?
Are they task-oriented or chit-chat?
Ivan, you can clarify your question if you don't mind.
Yeah, I had in mind task-oriented chatbots, for instance, for interacting with users on the website.
Okay. What kind of advice do you look for?
Okay. I may have to clarify a little bit more. So basically, for sales chatbot for on the company website for giving answers about the company and kind of selling the product to the customer.
Okay, I think I got it. So, okay, we had actually experience with one of the customers last year building exactly a sales chatbot. So what we did last year, we picked a different framework, not DFF, because it didn't exist back then. We used a different framework called GoBot. It's also one of the things we built. What it is doing, it's like Rasa in a way in the beginning. So you give examples of conversations to the system. And based on that, you provide responses or using a learning trained policy. But the reality is it doesn't work. And we had to enhance our system. And this is actually one of the reasons why I went to this slide, is because this is one of the things we are working on. So in the beginning, we used examples of utterances coming from the customer, examples of dialogues. We train the system based on them, but the system goes based on this data, but then it goes left and right and it stops working well. So instead of that, we decided to generate a dialogue graph automatically. And then we supplied this data to the system, and then we did two things. In the beginning, system tries to talk to the user based on the trained policy. The policy is learned from the dialogues. But then when the next move would be repeating for the system, we make a fallback to that automatically constructed graph, and we pick the response based on the graph. And this combination of automatic approach and knowledge graph, sorry, it's not a knowledge graph in the sense, it's a conversation graph, allowed us to make a bot that can actually sell things to the people. As a researcher, I'm not super proud of the fact that we've built a chatbot that can sell things to the people, but as a product guy, I say that's quite a nice story.
Thank you.
Awesome. Thanks everyone for participating in the talk. Thanks, Daniel, for finding time to share about your what you're working on. It's really exciting. It's really great to see how it evolves further. And yeah, if you guys have more questions, if you want to talk to Daniel, please feel free to ping him on our Bug Out Slack. And this is actually the last meetup talk for this year. And our next, we will resume our talks like meetups early next year. And yeah, I hope to see you soon and on our next meetups. Thanks everyone.
Thank you very much for inviting me, and thank you all for all of your questions. Have a fantastic end of the year, and see you in 2022. Let's make it better than this one.
It just feels like like we're like this small camp of kids, and like we had like really cool fun summer, and now like we're saying goodbye to each other to meet next summer in the camp. Thanks everyone for being part of Bug Out. Thanks guys. Bye-bye.
Have fun, folks. Bye.
Have fun.